All right. Man, you would think over the summer this program would have gotten easier to use or
No,
something.
they just added more features,
They
which
just,
the buttons are harder to find, and we're both out of practice.
yeah, exactly. Um, hey, Pamela.
Hi, Fraser.
Where's Pamela now?
I am actually in a really cool location. I'm in a hotel up the hill from the Asteroid Casino, which is the casino that inspired Royale, the James Bond book by Ian Fleming. Next to that very famous casino is a conference center where I'm attending the European Planetary Sciences Conference and the Astronomy Education Alliance meeting, which are co-located. And so I'm really trying to clone myself.
And it's 10 o'clock at night there?
Uh, no, it's at 8 p.m.
Oh, okay, all right.
I'm on London time. That hotel, for those of you who don't know, is in one of the suburbs of Lisbon, Portugal. So I'm on British time currently.
So great. So hey, welcome back from your summer break. I'm sure if your break was anything like my break, all we did was just sit around, enjoy the nice weather. Perhaps
You were
maybe
such a liar.
you took a horse
You're a
ride or
terrible
two,
liar.
maybe. That's all I did. We swam a lot. Didn't think about work at all. So it was good. It was good.
You're only trying to revolutionize how problems are solved. That doesn't take any of your time at
No
all.
effort. I do that in my sleep. That's just a little side work. Yeah, no. This summer it was actually. I mean, as much as I love doing Astronomy Cast, it was great to have a sort of a break from all the broadcasting stuff to be able to focus on a lot of the other projects. And so over the summer is when we put in a lot of the big improvements that we're trying to make on all of our businesses, because over the rest of the year we're just spending so much time just trying to keep everything running. And so it's
Yeah.
great to sit down and go and have a deep think about how can we improve the way that we report on the news or find some of the stuff or all that kind of stuff. And so hopefully with the Weekly Space Hangout and even with Astronomy Cast, you'll see a lot of the improvements that we're putting in place over the next couple of weeks and months. So
Yeah, he gets to brainstorm and innovate. I write grants and pray for
perfect.
money and write more grants
Yeah,
and
exactly.
hope hard work will eventually win me the lottery.
Yeah. Cool. Okay, so if you have no idea what you're looking at or what this is, you have no experience, we are about to perform for you a live episode of Astronomy Cast. Now, this is going to be, I said 352, it's actually going to be 351, and it's going to be broadcast on our feed a week from now. So the episode that we are hoping to get out like today or tomorrow, I don't know if you got the
I haven't got the audio yet.
you haven't
I'm
got
still
the
trying to
audio
get a
yet.
hold of
Okay.
Brian.
All right. Is the live episode that we did at DragonCon, which was awesome. It was so much fun.
So it will be an unnumbered, extra
Yeah.
special, awesome, loud, and crazy episode.
Yeah, it'll be like DragonCon, live from DragonCon 2014, and it was great to see you in person and great to see all the fresh victims that were brought to me to ask all of the toughest questions. So the topic is the toughest questions in space and astronomy, and so I guess what Rain, who organizes the DragonCon Space Track, had thought it was going to be was, hey, what are all the how do we as astronomers deal with the really tough questions that people ask us? And I took it as, now's your chance to ask the hardest possible questions you can think of. And I have 15 years of experience of knowing what are the questions that all astronomers, cosmologists, space exploration people want to avoid. And so I just hammered the panel with them relentlessly for the better part of an hour.
And what I greatly enjoyed was watching other professional astronomers try their hardest to avoid answering Fraser's questions.
Yeah, and I started out with, I don't know is not an acceptable answer. So, and so they had to then come up with an answer. And, obviously the answer is I don't know, but it was great to sort of hear the thought processes, what's the current thinking in this and so on, right? Stuff like,
Right.
What does a black hole actually look like?
Yeah, no.
If you go almost as fast as the speed of light, will your spaceship turn into a black hole? What came before the Big Bang? Why is there something and not nothing? Things like that. Easy questions. How old are Saturn's rings? It was great. All right, well, let's get cracking. We're going to do a live episode. Today's adventure, Asteroid adventure. and we'll take about half an hour. We'll record the episode, and then we'll stick around, and we will answer your questions about space and astronomy. So if you are watching this, you should see the Q&A app, and you should have already posted a question or two into it. And I can see Michael Jobin, Thomas Traniker, Ronald Minch, who I met in person, which was awesome,
Cool.
Nancy Graziano, Guido Bibra, and Sylvan Westby, Prapti Sanghavi are all there. And so I just want to say hi. Say hi to all of you folks, and thanks for your patience over the summer. Let's get cracking. All right, and now we have to see if all of this creaky software on our computers still works.
We actually both had this horrible expletive. We don't have audio software on these particular computers, so there was frantic downloading.
Yeah, and hadn't put that back on yet, but it's good. I'm ready to go.
And I'm just on a computer I don't record on. So, okay, I press the red circle and it goes.
Yep.
Okay, I'm pressing the red circle. It's recording. It's going. It's
in
mono. Yes.
Nice. Look at that. It just. This is how we get you over to Audacity. Is you don't have time to soil your computer with GarageBand. All right. All right, let's get cracking. Here we go. Astronomy Cast, episode 351, Asteroid Adventures. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Great. Welcome back to the 2014-2015 season of Astronomy Cast.
And isn't this... So this is 2014, so this is our 8th season we're starting.
Yeah. 8 years of Astronomy Cast. Coming at you.
There are people that have started college and gotten their master's degrees while we've been doing this.
Totally. I would love to hear some stories. Oh, you should totally email us.
Yes, actually, that's an awesome idea.
If Astronomy Cast has somehow influenced your educational career and you started early on and you've been, proceeding through it, let us know. Email us at info@astronomycast.com. We'd love to hear it. So if you're hearing this, hopefully you will have already heard our live DragonCon episode, which will have gone out in the feed at some point in the last few days. So I hope you enjoyed that. And that is a taste of things to come. All right, let's get going. So Astronomy Cast 2014-2015 season begins with Rosetta's arrival at Comet 67P. Churiguri. Up close and personal. What will it take to explore, exploit, and enjoy the asteroids and comets hurtling around our solar system? And how does science fiction have it all wrong? So, Pamela, we're choosing this episode because, holy moly, we're about to land a spacecraft on a freaking comet.
Yes, and what I love is for the past year, I've been hearing people from the Rosetta mission go, no, we're not landing, we are harpooning, we are docking, we are not landing, there's not enough gravity to land. And today, through the entire Rosetta session at the European Planetary Sciences Conference, which is where I'm at, all day I heard people saying, we're landing on and because it's an impossible to pronounce comet, they said, we're landing on the comet, and all of their slides just said CG67P. It was kind of awesome.
Yeah. So the Churiguri, this is from Emily Lakdawalla. So, she works for the Planetary Society, one of the most knowledgeable people in, planetary exploration. So that's her name for it. I love it. That's what we're using from here on out. Churiguri.
The actual name, as near as I can pronounce it, is Churyumov Gerasmenko.
Cool. Your Russian is good. Okay, so let's talk a bit about. So the goal with this episode really is to talk about what does it take to reach these asteroids, to orbit these asteroids, to to be able to actually set down on these asteroids and comets.
And when he says asteroids, he means small bodies, including comets.
Yes, asteroids and comets. All right,
Yes.
so let's sort of like set the stage then about where these objects are in the solar system and what's involved to actually reach them.
So the things that we're going after in general are going to be somewhere out beyond Mars. So they're kind of a pain to get to. Um, when I say beyond Mars, they could be a lot beyond Mars. The Rosetta spacecraft had to put itself into a rather severe elliptical orbit in order to match the orbit of the comet that it's going to be harpooning and putting a lander onto. So you're going out far enough that you can still use solar panels, but if you do, you have to power yourself down a lot. You're going out far enough that ice has become an issue. Staying warm is always an issue. And time is the real annoyance because you're waiting 10 years, 11 years longer at your orbit correct to be able to do what you're doing if orbiting and landing is your goal.
Right, and so what are the main missions that have been part of this? I mean, there was the mission to Eros with
Mm-hmm.
Near.
Right. So
There's
I have notes.
oh, good. We don't have to pull them out of my memory.
No. That's just mean. So we've had Chang'e went within 5 kilometers of a little tiny cute asteroid. I'm just going over the ones that got really cute. Not cute, really close. They're cute as well, but really close. We had
Only the
Hayabusa.
close missions, please.
Yes. We had Hayabusa actually returned, is in the process of returning a sample from Itokawa. We had Deep Space One got within 26 kilometers of Comet Borrelli. Rosetta did a flyby of Comet Stein at 800 kilometers near Shoemaker, landed on Eros, and took all sorts of awesome images from 35 kilometers away. But for asteroids in general, most of the images have come from 1,000 kilometers or further away. And when we start looking at comets, spacecraft are even less willing to get close in. So with the early missions that were trying to get in close to Halley, we were looking at Giotto got within about 600 kilometers, and that's not that great compared to, well, Rosetta is going to be orbiting at about 30 kilometers up and then working itself down to a 10-kilometer orbit. Then we're looking at Stardust, got within 240 kilometers of VL2, and Temple 1 was approached by Stardust at 181 kilometers. So it's comets are not something you usually get nearly as close to, and this is probably because a lot of these missions were trying to stay outside of the blast zone. Comets are volatile. They periodically release all sorts of different things. My favorite comment of the day was looking at epoxy results of Hartley 2. And Hartley 2 is a comet that they call it a bilobate nuclei. It means that it's kind of barbell shaped and it has a waist or a neck, whatever you want to call it, around its middle. And that middle skinny section gives off water vapor, and the far end of the tail part of this comet, I was waiting for one of the scientists to say derriere or something less appropriate, but the tail end of this comet was giving off CO2. So you have these really neat structures that are giving off jets of different volatile materials. And getting hit by a jet is going to screw up your orbit. And you have to have enough fuel on board to compensate for that. And a lot of these missions aren't carrying enough fuel.
Right. And so, I mean, you've got these, as you said, you've got these, the material that's streaming off the comet that the spacecraft is going to have to deal with. You've got the irregular shape and spin of the object that the spacecraft is going to have to deal with. I mean, you can imagine one of these big asteroids tumbling and turning and trying to land. You've got to match this strange rotation that the asteroid's doing with your spacecraft.
You have a 12.4-hour rotation period of Chiriguri is what we're calling it, Chirigura.
67P, yeah, Chiriguri.
So you have a 12.4-hour rotation period of an object that is currently being described as a bilobate duck. And over, everyone was referring to it as a duck because if you rotate it, it does indeed look like a rubber ducky. It's two non-aligned objects that are connected by a skinny neck of material. The entire thing is not that many kilometers across. You don't really have gravity that's all that much to speak of. It's just barely enough to allow them to orbit. And so now you're trying to maneuver in to land on a rotating duck.
Yeah, not easy, not easy. Which is spraying material at you.
Yes.
So it's not an easy.
That is giving off a lot of the jets.
Yeah. So then, and I guess the other part of the problem is that the gravity is so low that any maneuvers that you make will push you, like it must be super hard to get captured by the very weak gravity. It's almost non-existent.
Well, and with missions like Dawn, which approached not Ceres, it's on its way to Ceres, missions like Dawn, which snuck up on Vesta, what you essentially do is you first match the object's orbit as it goes around the sun, and as you're matching the orbit, you slowly just basically puff yourself into an orbit that is spiraling around that object as you co-orbit around the sun.
Yeah, you're going to have to play some Kerbal Space Program to really know how to do this maneuver. I highly recommend it.
They actually have like full-on simulators where, as it was described by one of the women on the Dawn mission, she goes into a very, very cold room where they have a secondary version of the spacecraft, plug all of the maneuvers into this cold storage version of the spacecraft, look to see what happens, and then compare the outputs to what was expected.
Oh, that's really cool. Okay, visually. so let's specifically then talk about Rosetta, because at the time that we don't normally do this, but at the time that we're recording, Rosetta is orbiting 67P. It's about to send the Philae lander down, the Philae harpooner down. So how is this gonna work?
Right now, they're in the process of narrowing it down from 5 landing sites, 2 on the head of the duck and 3 on the body of the duck. They're trying to narrow it down to 1 landing site and 1 backup landing site. That will be announced on September 15th, so right after this episode goes live. They're going to then say specifically which one of the primary and secondary sites it is in October. And then in November, they're going to send that little lander down. And one of the big issues that they're running into is when you're trying to land on a moving object, you end up with error ellipses. We see the exact same thing when we land on Mars with the various rovers. There's this area on the surface that is defined by how well they think they can land, based on wind in the atmosphere, rotation of the planet, and all these other factors. Well, Chirigura doesn't have an atmosphere to worry about, but it has these jets, and its gravity isn't exactly mapped out perfectly, and so you still end up with an error ellipse because it's a rotating object, so it's an ellipse, not a circle. The ellipse is 1 kilometer in diameter. It's called a 500-meter error ellipse or landing ellipse. And they haven't found any flat areas that are that big. So landing is actually a much more difficult process than they thought it was going to be. They are also struck by the fact that they can't actually get in at the neck, for instance, because how do you maneuver in there? They just don't have enough fuel on the lander. There's issues of, well, if you're orbiting this way, you can't actually get to all parts of a spinning object. So there's a ton of constraints in terms of just the dynamics of the system and what orbital mechanics and the amount of fuel. They refer to it as the amount of change in velocity that you have on your lander and your spacecraft. So you take into account what you can do. You then start looking for sites that are big and smooth. Get a little sad because you can't find them. Start looking for things that at least have the surface parallel to gravity. Because one of the other problems they're having is this is a silly looking object that is sloped in all sorts of crazy directions with respect to that insane gravitational potential because it's rubber duck shaped.
So let's, it's hard.
Yes.
And they're going to figure it out. And so in the case of Rosetta, it's going to take this harpoon on the Philae lander, it's going to jab it into the comet, and then it's going to reel itself in and try and land.
Yeah, and this is another one of those things that they don't take into account in movies like Armageddon. One of the many things that had me kind of screaming at the television set during the few excerpts of Armageddon that people who love me still let me see. They land on this comet that is nominally kilometers across, and they're walking around.
It was 1,000 kilometers across. It was as big as Texas.
It's still not going to have that much surface gravity.
Yeah. Well, even in like Deep Impact, it was only more like 10 kilometers, right? You wouldn't, and that was a comet, and you wouldn't be able to stand on it. Yeah.
So you have this super low gravity surface, and if you try and just gravitationally land on it while it's spinning past you, it gets tricky. So by harpooning it, it guarantees that you match that rotational velocity, and you essentially reel yourself in, and suddenly it makes the dynamics a little bit less scary to deal with.
Yeah, I mean, we had a ad hoc landing with Near when it landed on Eros, right?
That was sort of awesome.
Yeah, I know, and it sort of slowly made its way closer and closer and closer, and then just landed, and survived.
Yeah.
Briefly. And was able to provide data. But hopefully the Philae landers can do a better job. So let's talk about the science then. So what kind of science are astronomers looking at, both in the landings they did with on Eros and the Philae lander and future missions? What unsolved questions they're trying to get to the bottom of?
Well, at the end of the day, asteroids and comets are leftover material from the formation of our solar system. They haven't been processed through all of the different things that happen on planets like Earth that cause you to have silver mines in one place and uranium in others. All of this differentiation processes that we have and other large objects have, comets and small asteroids don't have the same way. So when you get up and explore these things, it gives you a chance with the sample return missions, with the spectrometers, with all of the instrumentation, to start to get a sense of what were the original ingredients that made up our solar system before they got processed by all of the things that happen when you have chemistry happening on a body. Here on Earth, we end up with all sorts of complex things that weren't formed in the solar system, but were formed here because we have weather, because we have so much gravity, and because we have tectonics. Now, we find that objects like Vesta actually are differentiated. We didn't know that, and that's kind of cool. And the Dawn mission, it's looking at bigger things. It's looking at Vesta and Ceres. Here it's looking at two large, almost planets that are on either side of the solar system's ice belt. So here you're looking at things that formed on either edge of a very special line in our solar system's formation. But when we're looking at all of these smaller things, we're basically going, okay, what were the raw ingredients before we baked the solar system through planetary differentiation? What's cool with Rosetta is they're actually going in and they're looking for organics that formed naturally. They're looking to see what is the mix of chemicals, what are all of the awesome things that happen when you look at the debris that comes from the outskirts of the solar system instead of the outskirts on the inner part of the solar system.
Right, and 67P is a long or is a short period comet, right? So it's one that's been orbiting within the relatively inner solar system for billions of years, and so it isn't fresh in the way that for example, some of the new ones, like the new Siding Springs one that's going to be going past Mars shortly, is things like that. And so it's going to be a different creature. I mean, that would be the dream, right? Land a lander on a comet where
And
that's come from the Oort cloud, right?
But the problem with things coming in from the Oort cloud is you don't have enough years to match their orbit between when they would get detected out by Jupiter, if you're lucky, and when they come in towards the inner solar system. With this particular comet, it's not even coming all that far into the inner solar system. It's going to get in around 3 AU, and that's awesome, but that's not a sun grazer, and it's actually a whole lot safer for the spacecraft because it's not going to have huge amounts of activity like you would if you got too close to the sun. But if you're looking at one of those outer comets coming in, you're not going to get a super precise orbit. You're going to basically be throwing rocks at a moving target, and you don't have enough years to throw that rock. So yeah, it's awesome. It's a dream, but don't know how you do it at this point. We just don't have the ability to get things going fast enough.
I believe that's why I said, man, wouldn't it be cool? That's why I did my empty speculation. Because beyond that, right, being able to get up close and study one of those comets is important.
Yeah.
Because we need to understand what their constituency is. What are they made of? How dense are they? How do they behave? Because as we watch with Deep Impact, the goal would be to eventually be able to move, shift, adjust, harvest from these comets, and so to actually.
I'm not sure we're going to harvest a comet. They're like water and CO2. We've got those.
But part of the challenge with these, like, if we can't even get to one of these comets to be able to figure out how to move them or even study them, how are we going to be able to move them and protect the Earth from these if they're going to eventually impact us? So anyway, that's a whole other rabbit hole. We don't need to go too deep down into that.
So a rabbit hole that you probably are thinking about that makes these things interesting in a different way is when the solar system formed, you ended up with a different mix of stuff at different distances from the sun. This is how we know that the Earth and the Moon came out of the same lump of stuff, as we have the same different isotopic ratios. Mars is made up of a different ratio of stuff. This is how we're able to identify Mars meteorites when they land on Earth. This is how we're able to say these meteorites all came from the same parent asteroid. As we look at things that came from different distances from the sun when they formed, we're getting a different sampling of that original solar nebula. So objects that come from the Kuiper belt for their origins are going to have a different composition than objects that came out from the Oort cloud. So beyond the whole protecting Earth, which isn't a way to justify spacecraft with Congress, the whole let's get a teaspoonful of the outer solar system, that's basic science, basic research. You can at least usually get a small mission out of that sort of an idea.
Yeah. So one of the things as well, when I look at the pictures of 67P, is duck. The flying duck. It looks like a little eagle, an eaglet to me. Is how much it looks like an asteroid. Like
that's because it doesn't have
like a comet.
It doesn't have jets that are visible with the contrast that allows you to see the surface. This is one of those things that is really frustrating. Is it does have jets. It does have a mission right now. It doesn't have a giant, awesome tail. It doesn't have a big, fuzzy coma. But it is giving off stuff. But you can only see that stuff if you play with the contrast to the point that the surface of the comet is completely saturated. So when you turn down the contrast so that you're making out the surface features, you lose all of the jets that make it look like your quintessential comet. Now, at the same time, I wouldn't say it looks like an asteroid because the sucker isn't all cratered. It doesn't have craters. Mm-hmm. It also, it's much more jagged with many more sharp edges. And asteroids in general are a lot more rounded in their appearance and lack these sudden plateaus and chasms that you see with the ice fractures all over this object.
It looks like, and I don't know if you get this there, but here in Canada, when we go up to the mountain, we have this great big, like it snows tons in the wintertime on the mountain because it rains
Yeah,
here all winter long. And so we get this almost a channel that you have to drive through on your way up the mountain where it can be 10 meters of snow that you're driving up
right.
through. And so you've got snowbanks on both sides, but then the actual ground is dirt and mud and muck, and the cars are driving through it, and they're
And
spraying up
it's,
this dirt, and it's
yeah,
covering all this snow that looks like, looks like snow, but it's sort of half melted and iced and whatever, and then it's all covered in dirt. And
yeah,
it is like gray, looks like
totally looks
someone
just like
painted.
that.
Yeah, someone just painted snow with mud, and
The,
that's what it looks like to me.
one of the awesome things that happens is with a lot of organic compounds that form naturally, when you expose them to ultraviolet light, which the sun has, they blacken over time. This is one of the awesome things that creates dirty snowballs out of really old comets. And there's actually a few objects that have been misidentified as asteroids because they're very old comets that have used up the most volatile parts or have caked over the most volatile parts. So as they pass around the sun, they're just going, okay, I'm covered in organics. I might have a little jet over here. But in general, they're just coated in dark sludge. And
Yeah.
this is a sludgy object still. It'll shine up as it gets a little closer to the sun.
And that'll be really interesting, right? Which is, and I think that's one of those scientific questions, is what exactly happens as it warms up, as it gets to the point that these jets start to appear and start to erupt out of the surface of the comet? And wouldn't it be amazing for the lander to be close to one of these jets,
And that's the
not
plan.
under one of the jets, but not on the business side of one of these? Although it probably won't be too much of a problem for it. Like, it's not going to be blasting jets. It's going to
Yeah, well,
be, what's it going to be, I guess.
well, I mean, so the thing to think about is if you've ever watched dry ice, it gives off like nice, pretty clouds of material. These get used to create fog when you don't have a fog machine. But if you blast, and I don't recommend this, if you blast that dry ice with a creme brulee torch, you'll get a jet of material trying to escape as it rapidly sublimates. And that rapid sublimation is the same thing as a jet forming. And what you end up with on comets is most of the surface is sludged over, but as the surface melts, you end up revealing a pocket of more pure material that just jets. And that's kind of volatile. Now, this probably won't happen, but there's the minuscule chance that they'll harpoon into something that just decides to jet back off, and that would be a bad day. But what they're hoping to do is actually land near activity, but not on an
Hmm.
active region.
But it's hard to know when you're looking down, when you're mapping. I guess this is part of the landing process, is they're trying to guess and go, which parts will probably not have jets? Or,
And this is where they use spectroscopy to try and understand what are the different things in different parts of the surface. They're trying to land near organic materials. They're trying to land near an active region. They have a ton of constraints. I do not envy the group of people who are choosing that final landing site,
yeah,
but
yeah.
they want to do all the things you want to do, so you'll be happy.
Yeah, no, it's just an amazing mission. So then, before we wrap this up, I would love to know what would be sort of the next dream mission if you could sit down and hammer out the requirements of another mission that would interact with a small body in minor body in the solar system. What would you want your mission to do?
So if I was looking at an ultra low cost mission, I'd want to take one of the Earth crossing asteroids that gets fairly close, but not too close, and actually try out, so what happens if we paint that sucker? That's just a cool idea, and if you paint one and then you can send the spacecraft off to do more science, I don't know how you would paint it at this point, but I know there's people that have worked to figure it out, and the idea of painting an asteroid just makes my heart giggle. If it was a more expensive mission that allowed if the sky was the limit on cost, I'd
Which
want
it
to start
is.
to.
Allow me to write you a blank check.
I would love to be able to start doing, no matter if they're only a few feet deep, I'd love to start doing core samples instead of just scraping off a small level. Just imagine being able to dig even 10 feet into one of these objects and see how thick is the crust, see what is the diversity, and start doing those core samples.
Yeah, I mean,
It's hard, but
here on Earth, core samples tell us so much about everything. We use silt samples from the bottom of lakes to tell us about the plants in the region. We use core samples in Antarctica to look back at the levels of carbon dioxide and the constituents of the atmosphere. We use rock samples to look back at the layering and we find out the mass extinctions. So same thing. You dig in and produce a core sample on one of these comets or asteroids. Comet might be easier. You're going to get the history of the solar system.
And where it starts to get problematic is that would be a hugely energy intensive mission, and it would need to be big and sturdy and able to withstand all sorts of shaking, and it starts to become an engineering problem that we're not quite there yet.
It should be covered by my blank check. Don't worry about it. All right. Well, Pamela, thank you so much.
My pleasure. Thank you.
We'll see you next week. All right. Don't anybody go anywhere. We will save, and we'll take some more questions.
I don't. Yellow square? Yes, yellow square.
Yellow
square looks like it should be. The colors on this have me verklempt. Okay.
I will send your feedback to the Audacity team. And so you want to save it as an Audacity project, and then you want to export it as a wave. But make sure you export it as a wave, because if you try to export it as a MP3, it's going to complain until you put in all the appropriate plugins.
Oh, that's frustrating.
No, wave is better for Preston anyway.
Yeah, I'm just, okay, this computer, I will figure that out later because I need to add the Dropbox folder for Astronomy Cast.
So, Simon Love notes, by the way, the Kerbal Space Program is on sale right now for $16.19. Normally it's $27 for the next few days on the Humble Bundle store. HumbleBundle.com/store. Yeah. And so you're going to love this. So Logan has been really wanting to play Kerbal Space Program with me, and so we've played it a ton, but so we're using Twitch, and we actually live streamed us playing Kerbal Space Program.
Oh, and
I didn't tell anybody because I just wanted to get the technology working. So we've started the campaign mode in the Kerbal Space Program, and we played an hour of it poorly, and so we're going to keep going on that. We may start again and do it from scratch, and we'll do the live stream on Twitch on a regular basis. Now, I don't know whether that sounds like it would be awesome or like nails on a chalkboard, but if you want to participate in that, let me know, or you want to watch.
Do people get to hear you and Logan talking?
Yeah. Me and Logan on camera talking to each other while we're making our spacecraft and killing Kerbals. It is, it's hilarious. But we're not good, right? We're mediocre.
Right. No, we did this during the Astronomy Cast Hangout-a-thon, and I have never laughed at Nicole quite so hard.
Yeah, and so we're trying to understand what's expected of us, and we're trying to figure out what the mission is, and then we're like, pop the parachute. We gotta pop the parachute between 7,000 and 10,000 meters, and we're like, oh no, and then the Kerbals explode, and it's fun. It's fun. We're having a really good time. So if people are into that, we will probably do like once a week. He and I will live stream on Twitch us playing the Kerbal Space Program. So I'll keep people posted.
Okay.
It's fun, and boy, I really recommend if you aren't playing Kerbal right now, please play Kerbal. It is, if you want it, because there is a mission where you have to land on asteroids, and it's really hard because they're so light, so little gravity. But all of the orbital insertions and trying to catch up to spacecraft and docking, and it's super fun.
I just wish they had an iPad version, because it turns out the only time I play games is when I'm on airplanes too tired to work.
It would be great. It's a fairly, I don't know, it's a fairly simple program. I mean, it's a physics engine, right? And I wonder how well the iPad would be able to handle it. But the graphics aren't that complicated. It would be great if they did a one, like even like a trimmed down version of the game that
Yeah,
would run
I
on the
would totally be all
yeah.
over that.
Yeah, they're a great crew out of they're actually in Mexico City
Okay,
is the
cool.
company.
They're in the land of volcanoes.
Yeah. Okay, great. So Nikolai Ivanov's notes, to be fair, and talking about Armageddon, they had these turbine fan things on their costumes in Armageddon that pushed them down onto the surface. Still, don't know how they work because there's no air for the fans, but there you go. So great, yeah. So
So
someone else recommended um, a live, Ranko Prozo, friend of the show, asked, can we get a live Armageddon commentary someday?
we
You,
should
me,
totally do that.
Phil, Mystery Science Theater, Armageddon. Do you think he'd be up for that?
I would be up to that, and I actually haven't seen the movie all the way through, so the reactions would probably be pretty fantastic.
Yeah. So the way this would have to work is we would be watching the show on headphones, and then we would be recording we'd somehow
Riff
queue up.
track.
Yeah, we would queue up the episode, and then we would watch the show, and then you, dear listener, would then have to listen to our podcast while you watched Armageddon.
Is Armageddon Amazon? You don't get Amazon Prime in Canada, do you?
No, but we can figure out some way that I can, if it's not on Netflix, it's not on Amazon Prime, I can, rent the DVD somehow or buy
I'm
it.
just thinking if it's on Amazon Prime
Yeah.
streaming, that makes it easy. We could do it as a live hangout while
Yeah.
watching it.
Yeah.
Um,
Well, I'll be in the United States in October. So anyway, I will talk to Phil. We'll see if that's something he'd like to do, or maybe Emily would be fun, or
yeah, because she
know.
actually speaks comets better than
Yeah,
Phil.
yeah.
Or it's her boat.
I mean, we can go far up the chain. Carolyn Porco. Anyway, we got some connections that we could talk to. All right, I guess a great. We wanted to do a riff track. We had originally wanted to do a riff track of Cosmos and the original Cosmos, but we didn't want to make them mad at us. So, okay.
But riff track's kind of the wrong word. I'm going to go through and basically do the no, that's not true anymore, which is different from making fun of them because gravity.
Yeah. So Thomas Traneker asks, what speed are we talking about at a 10-kilometer orbit? And so I guess the question is, like if you're 10 kilometers away from the object, what kind of
speed? And the object is only a few kilometers. So assume, I don't know how many times they go around it, and I don't know its mass, so I can't do math in my head. I can look all these things up, but I bet if you go to the ESA Rosetta page, they already have it for you.
Yeah. Not fast.
No.
Very slow, because if you go too fast, you're going to break out of orbit, and you're going to
and it's tiny. You don't have to go that fast to get around it.
Yeah. So you're not going very fast, and you're not going very far. So, but we haven't done the math. Rich Hayward wants to give a plug, which is a great point, which is that Matthew Francis's Black Hole 2 class begins tonight.
Yes.
Pitch Cosmo Academy, Pamela.
Cosmo Academy is our program over at CosmoQuest that allows you to take adult ed classes on different topics in astronomy. We bring in experts who do short courses anywhere from 4 hours to 16 hours, depending on the topic. If you're a teacher, we can get you continuing education credits. And we do force you to pay money, but that's because we pay our instructors so that we can get good instructors. So check them out and consider signing up.
That was great. I'm going to kick it up a notch.
Okay.
So listen, if you're listening to this podcast or you're watching this podcast somewhere and you're thinking, hey, I'm interested in space and astronomy, I wonder how I can take this to the next level. Wouldn't it be amazing if you could sit and talk with and learn from a PhD astrophysicist who is one of the best people that we have ever met, who knows these kinds of information in cosmology and black holes and astrophysics? Wouldn't that be amazing? And you would literally be in a small class and download directly from his brain to you the things that you would learn. Because this is what I get to do, right? I get to talk to Pamela. I get to ask her any questions I want. She's there to to be able to teach me and you about all of these things. Well, now you can specialize, and so we are recreating the Astronomy Cast experience for you. And so if you have any interest in this, I'm not even sure if the class is full. You really should sign up. Like, what's the price? A couple $100?
Yeah, well, I think this one's a short course, so it's only $99.
$99 for 4 hours of Matthew Francis's time to teach you about black holes. And he's
You can go to cosmoacademy.org or cosmoquest.org/Cosmo Academy, but really just go to cosmoacademy.org.
Yeah. So if you're a fan of Astronomy Cast, if you're a fan of space, science, astronomy, you should take some of these courses. And because the more people who take these courses, the more demand we're going to get, the more people that more teachers and instructors we can get on board, the more variety of classes we can provide. And this is all part of our grand vision, right? The grand vision of Astrosphere and CosmoQuest specifically is that we want to help regular people participate in the creation of science. And so you can, and then we want to help teach you more about the science so that you can participate at a higher level, so that you can do more complicated work. And so this is all part of this process, and we're still figuring this out. But with CosmoQuest, you can help map out on the moon, and then you can take a class from a lunar researcher about how this all works, and then build that and blend that knowledge. So this is how this is going to work, and really recommend that you get involved.
And so it starts tonight.
Yeah.
There's still a few seats open, so you go ahead and enroll. It's $99, and we'd love to see you.
Yeah.
I'm going to be teaching a course once we're in the process of figuring out how to get the courses run through SIUE so that you can get some sort of a, not degree, but a certificate of enrollment through the university. And once we figure out the paperwork for that, I'm going to be teaching a calculus-based physics class for people who really want to get down and dirty.
Oh my God, this is so good. So WA59MX says, fun fact about Armageddon, NASA shows this film during their management training program. New managers are given the task of trying to spot as many errors as possible. At least 168 have been found.
Oh, God.
Yeah. We should do gravity as well. Oh, this would be so much fun. I wish I had more time. Someone please manufacture more time. That would be super.
So just imagine the amount of life that you'd get back if you never had to do paperwork, if you never had to fill out taxes, if you never, all of these things that don't require our creativity and ingenuity that are required because money exists. Just think of what we'd be capable of. So donate to our programs so that we can pay other people to take this stuff away from us.
So that we can do a riff track version of Armageddon.
Yes.
Yeah.
And we are going to be bringing Patreon soon. We're in the process of finishing up the paperwork to do that. So Astronomy Cast is going to be adopting Patreon.
Perfect. And if you're looking for a Patreon to contribute to, go check out the Universe Today Patreon.
Yes, and they actually have a Parsec award-winning podcast.
Yeah. Yeah. No, we were up to about $1,500 on Patreon, which is fantastic. Cool. Okay, so Ranko Prozo asks again, do we ever find objects that come from outside our solar system?
Yeah. Well, not objects. We find dust grains. It's an object. It's just a tiny one.
Interstellar grains of dust. Yeah.
Aim small.
Which tells us about the formation of the entire galaxy.
And it tells us about the formation of that dust grain.
Right, which is part of the galaxy. Okay, why didn't that get processed? Okay, Michael Jobin says, I don't know if Rosetta will be there after it goes around the sun. It would be a great photo op. So yeah, it's. So
the mission nominally ends December 31st, 2015, because that's when its budget ends.
Yeah.
So the question is, will they be able to get a budgetary extension? We never know. Cassini was supposed to have died many years ago, and it's entering its 10th year, and it just got extended again. So if the science is good, if the lander lands on its feet, sky's the limit. But funding's always the issue because you have to pay the salaries for the people controlling the spacecraft, pay the salaries for the people doing the science. And yeah, the spacecraft's out there, but we still have to pay receiver time and salaries, and that adds up quickly.
Simon Love asks, do we know where the comet originates from? In this case, Chirigiri.
Yes, but that's not in my head right now.
But
Sorry.
it's a short period comet. It's been doing this since the beginning of the solar system.
Well, no, because they actually get knocked in via different processes. So they end up ending up in the inner solar system at different points. So this one's orbit has actually been getting evolved rather radically by Jupiter. Prior to 1959, it had a closest distance to the Sun of 2.7 times the Earth-Sun distance, 2.7 astronomical units, but a close encounter in 59 with Jupiter moved it inward to 1.3 AU. So this is actually getting in closer than I thought it was. But yeah, it's a pretty awesome object. But they get their orbits evolved, and so we can't say it's been doing it since the end of time. We can say it's been doing it at least since we discovered it. And I'm trying to find the year that it was discovered. Yeah, I'm not seeing the year it was discovered quickly. I'm finding pronunciation guides quick, which is kind of funny.
Awesome. All right. Well, let me just. I just checked all. I think I got all the questions in the Q&A app. Let me just see if there's any questions over on YouTube. Google, if you could make this more complicated, that would be awesome. Just, that'd be great.
So here's something that intrigues me. The Wikipedia article refers to things in 1959, but the cometography article talks about it being discovered in 1969. So take that as you will and find more data.
Right. Unknown when it was discovered. I'm trying to see if there's any more questions. Over on YouTube, there's a few people watching us. All right, let me see. The best place is to ask your questions in the Q&A app.
Yeah, I don't have Twitter open right now, otherwise I usually follow that. But as you can tell from the fact that I'm looking over here, I have a very weird setup right now.
Yeah, so a few people noting about DragonCon, so I hope I explained that over on Google Plus, that the live from DragonCon episode will appear when it's ready.
Once we get the audio.
Yeah, and so the way it goes when we're at DragonCon is the runners for every track that will record the audio from all of the things that we do, the sessions we do. My guess is that episode is out there somewhere, because I was able to find the Cord Killers episode that we ran before it showed up on the Cord Killers site. So somebody clever wants to try and dig through the DragonCon.
Let us know.
Yeah, let us know if you can find it, and then maybe we can shortcut this whole process and just extract the audio out of that video. But yeah, go ahead and so I'm sure it's somewhere on the DragonCon website. There's a lot of material on the DragonCon website. So yeah. Cool. Okay. Well, hey, Pamela, thank you so much. It's great to be back. I know you are probably time for bed there, or.
My body doesn't know when I am anymore, so yeah. I should go to bed, but my body is simply saying we should go play Plague more.
When do you return? When does this conference end?
I fly home Saturday.
Right on. Awesome. Okay, well, hey, I know I speak for everyone when I say it's so great to see you again. We're so glad you're back, and we're running these episodes of Astronomy Cast again. Here's to another great season of Astronomy Cast.
Here's another year and awesome science.
All right. We'll see everyone.
Bye-bye.